All right, this isn't the notes titled Geometry Notes 1-3 again. This is just an addition. It's getting in a little bit more information that your book had given you. An angle, you're just gonna fill in the blanks here, okay? An angle is a plane figure formed by two rays. So you're going to write the word rays in that blank with a common end point. Called the vertex. Okay, you know what an angle looks like. You studied these in your Rebecca book. Looks like that. Here would be your common endpoint, that dot I'm drawing. Here's one ray, and then the other ray, I'll put the other arrow. So that's why we say that it's joined there. The measure of an angle is given in degrees. At least that's how we study it now. When we get in trig, we talk about radians, which is another way of measuring it. There are 360 degrees in a full circular rotation. Okay, now here's the protractor postulate. For every angle, you want this in your proof book. For every angle, there is a 1-to-1 correspondence with real number degrees between 0 and 360 degrees. All this is saying is, if I take this angle that I drew up here and I put a protractor on it, I can measure it, and it's only going to come out to be one thing. It's not going to come out to be 15 different things. Now, we may measure it to different degrees of accuracy, and maybe the person next to you thinks the line fell here on the protractor instead of a little further up. But this just saying that, when you measure an angle, you're only going to get one measure. That's what that 1-to-1 correspondence means. All right, now these things you should be really familiar with. Acute angles are between 0 and 90 degrees. This is just a reminder for you. A right angle measures 90 degrees. Obtuse angles are between 90 degrees and 180 degrees. Remember, you can always pause the video if I'm going too fast. And a straight angle measures 180 degrees, and a straight angle is basically a line. Okay, so you could say the vertex right there, whatever, but this is 180 degrees. It forms a line, and we're going to use that heavily in geometry this year. Okay, the bottom of the page, congruent angles that have equal measures. So we can say, let's say that I name an angle A, B, C, and we can say that it's congruent to angle, let's say another angle D, E, F, if they're the same measure. That's saying the angles are the same size. I can also say the measure of angle A, B, C equal the measure of angle D, E, F, and that's talking about the number of degrees that they both equal. And again, D, E, F, let's say. So you'll see these used interchangeably in your book. Used to be, it was a big deal. Nowadays, not so much, okay? So you could put the two angles are congruent, but when you see that M in front of an angle, it means the measure of that angle. It's talking about the number of degrees it is, but these two things basically in your book are going to mean the same thing. All right, so now if we look down at the angle addition postulate, it says that if you've got like an angle, and let's say you got a point in the interior, okay? So the word that goes in this blank is interior. And let's say I came in, let's say that this is point S, and let's say I've got angle P, Q, R. And let's say that I come in, I'll use a different color to do this, and I draw a ray. Let's see, there would be these arrows on these that I forgot to draw, but on that red ray that I drew, if that's point S, then I could say PQS. Let me outline in different colors. PQS would be this angle. So see how they wrote measure of angle PQS just like I did over here. And then they say the measure of angle SQR, that would be SQR, because remember this is S here, would be the whole angle PQR. Basically, if I take an angle and I chop it up into two smaller angles, the two smaller angles add up to the bigger angle. That's all that's saying. People get all weirded out and upset about that postulate, and it just means if I take an angle and divide it into two smaller ones and put them back together, they're the same size. Now, what an angle bisector does, it is a ray that divides an angle into two equal or congruent angles. Notice bi means two equal parts. So if I had this angle here and I drew a bisector in, maybe it goes right down the middle, and I would show that these two pieces are equal by drawing an arc. That's the little arc, kind of like the tick mark we did on the segment. If I draw one there and I want to show this one's equal to it, I could draw another one here. I'll put my little arrows on like I'm supposed to. That one mark on each angle shows that they're equal, so I would know that this line, let me trace it in blue now, I would know that this is the bisector if these two pieces are equal. Again, going to be used heavily, heavily, heavily in some of your proofs that you do later on. Okay. Okay, just like we had the theorem that said we could add, or the postulate that said we could add two little pieces of a line together to get the whole length of a line, we have the same thing for an angle. It's as if we have, if S is in the interior, let me just go ahead and write that in there, interior of PQR. Okay, so let me draw a figure. Here's P. Let me draw the little arrows first. This is Q. I know Q is the vertex because the number in the middle when they name an angle is always the vertex. So we got Q here. P, if I'm talking about PQR and I draw S in the middle, okay, I'm going to go ahead and make a ray that goes out to S. Then PQS plus SQR is PQR. That's the angle addition postulate, the two parts out to the middle. We may have already done this one. Yes, we did. Sorry, I'm repeating information because I have a page where it's written bigger that printed out. Okay, that's it for this one then. We'll just stop this video here for that 1-3.